Hi, my name is Brian Choi, and this is my class presentation for 4934. Okay. So my topic is about finding alternative energy sources, and I'm going to attack or go in depth about fuel cells. So the background of why I chose this topic is to address our impending energy crisis. Most of human society uses fossil fuels or non-renewable energy sources to power their everyday lives, and it comes in the form of coal, petroleum, and natural gas. So, what do we do when these natural resources run out? We have to find a more efficient way to use our non-renewable energy sources, or we have to find different energy sources, such as fuel cells. And the diagram to my right shows the energy consumption of the world population versus time. And it shows how our energy available keeps on decreasing because the majority of our resources are from non-renewable, while our population is going to keep on increasing to the 10 billion. So we have to find a way to match this gap or find energy sources to supply the human population. And fuel cells is, I think, one way we can do it because it's clean and we can keep on doing it. So our current major energy sources are fossil fuels, which make up more than 50% of our energy consumption, and majority of it is through combustion engines, which we power. Every country in the world uses cars, trucks to transport things, and another source of it is nuclear energy power. It would be considered a renewable energy source in theory, but it's not because the materials we use for nuclear power are limited as there are rare materials such as uranium, plutonium, and thorium, which is really hard to find. And our remaining 12% comes from renewable energy, such as solar power, wind power, and geothermal power. And another way we can do this is fuel cells. So how I'm gonna put my presentation together is tell you the brief history of a fuel cell, show you what it does or how it works, and two different types of fuel cells and why fuel cells have been used in society. So, a brief history. Um, Fuel cells have been around for a long period of time. With since 1838, a German scientist, Christian Friedrich Sorben, created the first fuel cell using hydrogen and oxygen to create electricity. But even though this was made centuries ago, it hasn't been a major impact in our daily lives because it didn't produce a lot of electricity and it couldn't power a lot of things. So in 1959, Francis C. Bacon created the first applicable fuel cell to power a welding machine. It's called the Bacon cell. But since then, we haven't really found a practical and a cheap way to have fuel cells power our everyday lives. So that's why it hasn't been used. Later in the presentation, I'll show you or I'll inform you of the modern advances of fuel cells. So what are hydrogen fuel cells? Hydrogen fuel cells work with hydrogen and oxygen coming in and coming together and forming water, or H2O. In that process, we harness the electrons going from to form the bonds, and we use that to power machinery. One benefit of this fuel cell is it's a clean reaction because water, well, the only byproduct is water, which occurs everywhere on Earth. And an advantage is it's a flow battery, so it doesn't have to be recharged. Um, as as you keep on just putting reactants in, and byproduct comes out, and you keep on creating electricity. This is similar to a combustion engine, which we just put fuel in it, and it just works automatic, and then just keeps on working, and then we just put more fuel in it. It's unlike a regular battery, a fuel cell, because a battery works how we have to charge one side, and the electrons go into the other to the cathode, but we reverse the reaction by recharging it. So a fuel cell is very useful, and it's an open process, and that comes in stacks. So in order to make a strong current, we just stack them up together, and then um they'll make they'll make a bigger battery in essence. So to get to the chemistry of how a fuel cell works. So so in the anode, which is the left side of this diagram, hydrogen comes in and dissociates to form hydrogen ions and two electrons, which the two electrons go out of the anode, uh, and the movement of electrons powers your machine, and then the electrons come to the other side, to the cathode. And then the hydrogens go through an electrolyte or a membrane, which only ions can go through. And with the electrons, the hydrogen ions, and the oxygen that comes in, it forms water. And so that's your byproduct, and then you create electricity. So the advantages of fuel cells compared to our current energy sources that we use in our everyday lives, one being the combustion engine, and two being rechargeable batteries. So internal combustion engines only are 20 to 30% productive, as most of the energy that's stored in fossil fuels are dissipated through sound and heat. So that's not that efficient. So we need to find a way to make that more efficient, to prolong our use of fossil fuels, or we have to find different ways to power our society. So a problem with rechargeable batteries, even though they're very useful in our everyday lives, like our phones, so any device we use basically uses rechargeable batteries. They degrade over time, and they take hours to charge. So we can't use it to like constantly pump out electricity. But a fuel cell has a 70% efficiency in in the energy stored between the hydrogen and oxygen bonds. And to refill a tank of hydrogen, it takes about 5 minutes to power like a hydrogen fuel cell car. And it's environmental friendly, which water is the only byproduct. Oh yeah, side note, rechargeable batteries, they're usually powered through like non-renewable and renewable resources, because they like combustion engines, they generate electricity, and then that's how you charge the battery. So yeah. One challenge to hydrogen fuel cells are it's impractical in our everyday lives because there's not that many fueling stations. In 2018, only the U.S. had 39 fuel cell locations in the U.S. So majority of them are in California. There's like 2 in South Carolina, and this picture doesn't show it, but there's a few in the Northeast right here. And so renewable ways to produce hydrogen is underdeveloped, which majority of it comes from fossil fuels like a byproduct, and getting it out from the air, which is like a very expensive process. So so it's hard. It's a hard. We need to find a way to get H2 in a more effective way that is cheap, and that's the barrier to this. So our current advances in fuel cells is we have two fuel cells that are currently like used or majority used, and it is the PEM cell, is a polymer electrolyte membrane cell, which operates at 100 degrees Celsius and requires expensive catalysts. So, because it's expensive to use, it's not that practical, and we use it to power buses and cars. And the second one is FOFCs, which is solid oxide fuel cells, which operate at 1,000 degrees Celsius, requires expensive metal alloys to handle the high temperatures. It's expensive and it uses high temperatures, which is like very costly. So these powered hospitals and buildings. In order to make this, in order to make the fuel cells available in everywhere society, we need to make it commercially available. And in order to do this, the U.S. Department of Energy says we have to the cell has to produce 500 milliwatts per centimeter squared, and in order and recently a group did this in Northwestern University at Evanston, which they made a fuel cell more efficient by putting the anode closer to the electrolyte and increasing the layer of catalyst to speed up the process, like putting more PT or platinum in it. And so this made it meet the requirement. So hopefully later we can actually have fuel cells that are practical. I know BMW is having a project on fuel cells right now. So they're making like a fuel cell car. So that's interesting. So in conclusion, so we need to find different ways to supply energy to our population as fossil fuels are depleting. And fuel cells is a developing technology that's been around for hundreds of years, but we just need to make it more efficient that produce electricity through a redox reaction. It's also environmentally friendly, but the problem is it's hard to scale up and the material is fragile. So um, we need to find different ways to go overcome these problems. And so that's my presentation. Thank you for coming.